Hey, Zach. How are you doing this morning?
I'm doing good.
We'll wait a couple minutes and see if we can get anybody else to show up with us, okay?
Yeah.
I just uploaded this version of the notes that you see on the screen there. The one I had up there prior to this one didn't have anything highlighted, and I thought we could fill out some stuff as we go today.
Okay.
Are you able to make copies of notes on your own?
Yeah, I'm able to make copies of my own.
Okay,
That's good. I printed in my parents' room and I just hook up my computer with that.
Awesome. Okay. But even if it's, because one of my students said, well, they only had like, they could only do like black and white. It's really not a big deal because you can always go back to the notes that I have on the screen in Canvas, and you can see it color coded that way. So,
Yeah.
but I thought this might be a little bit easier. Our lessons are fairly short. Each one of the times that we're getting together. So this one's pretty short today also. And so I thought I could just run through it with you.
Okay.
Have you been able to look at the first two sections of the homework?
I have not. I was doing
Not yet.
homework yesterday. No, not yet.
Okay.
I'm going to
All
get
right.
today.
Okay, cool. Well, I'll tell you what, just for our time purposes, it may just be you and me, it looks like. So this is recording, and so what I'll do is I'll place the recording up there on Canvas in modules so that other people can look it over too if they want to, or if you want to go back through it, you can.
Okay.
All right. Well, the this lesson is over combinations, and the one prior to it was over permutations. And they're not really hard to calculate by any means because we have a calculator that has that keystroke in it, but it's knowing which one to use. Like, is it a combination or is it a permutation? And so the big deal here that I highlighted in my notes was the permutation down here in yellow. The permutation is the one we've already studied, and the order does make a difference in how you choose the items. So like one of the examples was, out of a group of 8 people, how many different ways can you actually select a president, a vice president, and a secretary? Well, the order would matter there because, like, if you're chosen to be the president, you can't be chosen to be the vice president. But if you were chosen to be vice president and someone else was the president, that's a different order. So that's how we know that's permutation. And so that formula is a little bit different. Remember, that one on the calculator looks like NPR, okay? The one in pink here that I have is called combination. And combination just means you can go out there and grab a handful of something. The order doesn't matter any time at all. If someone said, you get to go pick 2 flavors of ice cream, and you said first, I want vanilla, then you said, and I want chocolate. Well, the combination of switching those, chocolate, then vanilla, it's the same combination. So you wouldn't count each one of them as different. And what we'll notice here is the keystroke is going to look a little bit different. It actually is the NCR. And on the next page, we'll see, like how to plug that into the calculator. But here's what I was talking about. These next 3 examples are probably, to me, the most important thing, because it's not asking us to work the problem. It's just asking us, and I wrote down here, is this a permutation or a combination? And so as we read the problem, we have to decide, does the order matter or does the order not matter? Those are the 2 questions you're going to be asking yourself. Okay, so like under permutation here, I can go ahead and write, I'll put in here, order matters. That's not writing very good. And order does not matter. Just so we can remember which one's which. Let me see if I can do a better job of writing the word order. Maybe not. There we go. All right, so the order matters or the order doesn't matter. So let's read this problem. It says a yogurt shop offers 12 assorted flavors of yogurt. One of its items is a bowl consisting of 4 flavors, each a different flavor. How many such bowls are possible? So in reading that one there, do you think that it's going to matter how we go in there and pick the 4 different flavors? Or do you think the order's not going to matter when we pick the 4 different flavors? What do you think?
Oh man, you really got me thinking here.
Okay. Is there any, let's put it this way, is there any suggestion in that question that leads you to think that you would have to go and like scoop the chocolate first, then vanilla second, then the Rocky Road third? Is there any indication that tells you in this case that you're going to have to put them in a certain order?
Yeah, I'd say it does matter. Out of 12 assorted, there are going to be 4 flavors that you you want to have.
Okay. And so what if I were to make a bowl that had, like I said, I went in there and I scooped out the vanilla, then the chocolate, Rocky Road, and chocolate chip, okay, in that order. Is that going to be a different combination than if I choose chocolate, then vanilla, Rocky Road, and chocolate chip? Would your bowl have the same 4 flavors in it? What do you think? Here, let me go to this one here. Let me get this junk out of the way. Okay. All right. So here's the deal. And this is, like I said, this is the hardest part of the whole problem. To me, it is anyway. If you and I, in this bowl right here, that is not a bowl. Let's say that you and I have a bowl right here. Okay. And then we have another bowl right here. All right. And so in these bowls, the problem said out of those 12 flavors that we had, you can only pick 4. So if I pick chocolate, vanilla, Rocky Road, and chocolate chip. I don't know what letter of the alphabet that was. We'll do something like that. Okay. Now let's suppose on this other bowl here, I chose the vanilla, then the chocolate. I promise I know how to write. Using my iPad today just to kind of, so we can do a, make sure that this is going to be recorded. Anyway, the whole idea behind this is if they give you a chance to go in there and there's 12 assorted flavors and you get to pick 4 of them, okay? Will it matter the order that you pick them in? Do the 2 bowls here? Matter. Yeah, the order doesn't matter, does it? No. I mean, do your two bowls have the same 4 flavors in them?
Yes, they both have the same flavor.
Yeah. Exactly right. So this is one of those times where, you know, it really didn't matter if I went in there and I scooped out the chocolate first, then the vanilla, or for some reason the vanilla was closer to me, so I did it first and then the chocolate. It doesn't matter at all because the 2 bowls are identical to each other. Okay?
Yep.
All right. So if I go back to, hopefully, let me get out of here. Okay. And I go back in here and let me see if I can't get this stuff off of here for us. Then what they're telling us then is that you and I have what they call a combination here because the order doesn't matter. This would be a combination for this one. The order doesn't matter at all. Now, let's look at problem B here, okay? And so here it says that the medals are given at a race for first, second, and third place. There are 30 people running the race on Saturday. How many different outcomes are possible for these 3 positions? So the stuff in this one here that kind of gives me like a little bit of a clue about what's going to happen here. Let me get a color here. How about green? There, okay. Right here, the minute they told me that these medals are going to be given out as a first place medal, a second place medal, and a third place medal, that indicates order. Okay. So like if, let's say you come in first and I come in second, okay? Or I came in first and you came in second, it's the same combination of the two people coming across the finish line in that order, but the whole purpose here is it's an order, isn't it?
Yeah.
It makes a difference. So in this case here, this one would actually end up being a permutation.
Because matter.
That's right. It does matter. So some real easy indicators to look for will be when they start like naming people, like president, vice president, secretary. Okay.
Okay.
Once you select a person to be one of those three, they can no longer be one of the other ones. If they are not selected as like the president, but they're selected as the vice president, then that's a different order now because someone else is the president. Okay, so look for names like first, second, third places. If you're in a, like when you go to sit at a concert or something and you've got the first 4 seats, well, the order's going to matter. Yes, all 4 of you came to the concert, but do I get to sit on the aisle or do you get to sit on the aisle? So the order's going to matter there. Okay.
Okay.
All right. So let's look at this last example here. And it says, how many different 4-letter passwords can be formed from the letters A, B, C, D, E, F, and G if no repetition of letters is allowed? Okay. Again, like I said, this is one of those situations where, let me get out of this. Okay. This is one of those situations where, did they imply to us that you will pick the first one, then the second one, then the third one, then the fourth one? That's what we have to decide. Since it says it's a 4-letter password, and these are your choices. Okay. This fact that there's no repetition, basically that's just guiding us to let us know, you know what, once you pick the E, the next one can't be an E also. That's all that means. So the question is, does it, in this problem here, does it imply that we have to pick a certain letter first?
No, it does not.
No. There you go. That's right. Right then and there, we'll throw it over to a combination then. Okay?
Yep.
If they start talking to us about, like, you know, the first letter has to be a vowel. Okay, well, in our list here, A is a vowel, and so is E. Okay, so it does matter, you know, who gets to go first that time. But in this case here, they just flat out said a 4-letter password. No orders implied whatsoever. Okay?
Yep.
All right. Let's see if I can get to my other page. Should be down here. Let me get some of this off of here. Okay. So let me save that guy real quick. Okay. So on the second page of our notes here, this is kind of telling us how we would actually calculate a combination. And on these combinations here, they've got a different looking formula. Permutations, their formula looks something like, let me turn this sucker on. Okay. For permutations, we had NPR. And its formula, not that we have to memorize it by any means, but I just want to show you that they're different in a way. The denominator here is N minus R. Okay. So if you take a look at what's going on then, combinations, we said that the order doesn't matter. And so if somebody says something like, well, chocolate then vanilla, or they say vanilla then chocolate, this is really only one combination because the order doesn't matter when you talk about combinations. So check out the denominator here. The denominator for the combination has an extra divisor. See how permutations only has the one parentheses with the factorial? It doesn't have the extra part on it. This little extra part right here cancels out any duplications that you might have. Okay, that's his job. Again, that's really not, we're not really into the why the formula works. It's just there is a difference, and you will get two different answers if you accidentally use, you know, the wrong one. On the calculator, here are the keystrokes again. We still go to math, then the PROB, and then you choose the number 3 option. You're working with the 84 CE model, yep, aren't you? Yeah, okay. Yep. So yours is like mine. What you'll do is you'll just go in there, hit math, ROB, number 3. It'll come up like we were talking about Tuesday. Yours will look something like this, kind of like that on the calculator. And you just have to know, what do I put in first and what I put in second. One thing to always know, the first number is always the total number of objects that you're working with. Okay, it will always be the bigger number. Or the other box here will either be the smallest number or the same, okay, as the first box. Okay. All right, the way we say something like, it's not much different than permutations. We say we have 8 objects and we're going to take 3 at a time. That's kind of how we talk it. So if you take a look at this example here, it says, if in the card game of Go Fish, a person is dealt 5 cards from 52. All right, right there, we know that we have, get a different color here. We know that we have this many cards to work with. So there are 52 total objects. That's what N stands for. Now, when we're dealing out our cards, it says the order in which the 5 cards are received doesn't matter. And how many different 5-card hands are possible? All right, so what that tells me then is that this 5 cards that we're going to deal out, that's how many everybody's going to get at a time, okay? So we would say, I've got 52 cards. I'm going to go in there and I'm going to take 5 at a time. So we would set up the problem 52, C, 5. And I don't expect you guys to use the actual formula that you see up here. I expect you to use your calculator. You have your calculator handy?
Yeah, I got, what I got is a big, I know it's supposed to come back as a big number.
It's going to be big, yeah.
Okay, so it's 2,598,960.
What was the last ones?
960.
960?
960.
Okay. Yeah. These numbers are going to blow our mind, okay? Because what it's saying is that if we had just a regular card deck, 52 cards, you shuffle them, you start dealing out 5 cards to everybody that's there, okay? There are over 2 million ways to form a 5-card hand. See, that blows my mind. You know, because people think, well, there's only 52 cards. You can only make like 10 5-card hands then. No, because you and I could end up with one of the card hands might have, how about the 2, 3, 4, 5, and 6 in it? And another one might have an ace, 3, 4, 5, 6 in it. And you can imagine all the different ones that you and I can make. It'd be crazy, absolutely crazy. Yeah. So thank goodness the order doesn't matter, because if the order did matter, just for grins, put in your calculator the, go to the, math prob number 2, where that NPR comes up.
Yep.
Try put 52 and 5 in that one. I'm just curious.
2, 2, 5. Oh, you got a bigger number than that.
You got it. You got it. So what we find out is the number of combinations is always going to be smaller than or equal to the number of permutations. But I can guarantee you that the number of permutations, if it has a chance, it'll be the largest number compared to combinations, because now when they talk about order, I mean, cripes, they're talking about this hand here that was 2, 3, 4, 5, 6. Just those numbers right there, we could have rearranged their order and each one of them would have counted for us. It's crazy with permutations. All right, here's another example. It says you walk dogs for a part-time job in the summer. You have a client with 5 dogs. However, you only walk 3 dogs at a given time. How many different combinations are possible if you walk 3 of the 5 dogs? So again, the most important thing to realize, and granted, this one's under the combination section, so we know what to do, but can you tell that that's a combination? How they're not talking about like the order of the dog that you walked?
Yeah.
Okay. So how many dogs are there that you walk?
There
As
is
a
a total
total.
of 5.
That's right. So N's going to play the role of 5. And then how many are you going to take at a time?
3.
3 of them at a time. Okay. So we can say that there's 5 objects, or in this case, dogs, 5 dogs. And we're going to figure out how many 3 dog combinations we can make. Now this one should be smaller.
Yep.
What did you get as an answer?
I got 10.
Yeah. What this tells us is that there's really only 10 different ways you can take 5 dogs, okay, choose 3 of them, and then if you choose another 3, and then you choose another 3, there's only 10 different ways you can do that. Okay, and you can see that whenever this number out here that's called N, the number of objects is smaller than like before we had 52, you've got a really good chance of getting smaller numbers. Make sense?
Yep.
Cool. All right. This last one here talks about an election. So a lot of times when we're talking about elections, we're like, ding, ding, that's got to be a permutation. But make sure you read to see if they named the positions that these people are going to hold. This says an election ballot asks voters to select 3 city commissioners from a group of 6 candidates. And how many ways can this be done? They didn't tell us who was going to be what, did they?
No, they did not.
They just said pick 3. So it's a combination. Now, had they said how many different ways can we pick a treasurer, secretary, and reporter, then we go back and say, hold up, you named their spots, so that's going to be a permutation instead. All right, got the difference?
Yep.
Okay. So in this case here, what's the total number that we are choosing from?
6 candidates.
You got it. So 6 is going to go here for N. And then how many are we choosing at a time?
3.
3 of them. Okay. So 6 choose 3. So 6 combination 3 should be a little bit bigger than what we had before. What is it?
20.
20?
Yep.
Awesome. Okay. So that just means there's 20 different ways that this can be done. Now, I will not ever ask you to list all of these because it gets to be where there's a huge amount of work involved. But if for some reason, let me see if I can, let me just go across now. Okay. If you go in here now and try to look at one like that, then what we would be doing then, we could write them out at that point. That's what I want to kind of show you. Let me get out of this and go back. I hate that I have to do it this way, but Okay, there's our first page. Second. Okay, so here's just an extra page I put on my notes just so we can see them. I feel pretty good about us knowing the difference between permutation and a combination. How do you feel?
I feel pretty good about this.
Okay, so permutation, remember, it just talks about naming. Like here it says in the red, first, second, and third. Versus over here, it just says, in how many ways can 3 runners cross the finish line together? Well, that's a group. The order doesn't matter. Okay. But what I wanted to show you was just so that it makes sense, I guess, for a combination. It'll make sense if this turn on. Here we go. For a combination, if you and I had, let's make it small enough to where it's not going to be too bad. How about 4 choose 3? So there's 4 flavors. You can tell I must be hungry or something of ice cream. It's crazy. And you and I are going to choose 3 at a time. Okay. So I'm just going to put letters up here. Here we've got a B. We've got a C. We'll say a B and a P. Okay. Those are going to be our flavors of ice cream. And now we're going to make combinations 3 at a time. So one combination could be B, C, B, right? Another one could be B, C, then what? I could have BCP. Is that right? It's a different combination. You okay?
Yep. All right.
We could also have C, B, P. That's another combination right there. And the only other one that we have left would be what? B and P could go together. How about with B? Is that a different one?
Yeah, that's a different one.
Okay. Now, I think that's all the different ones we could have. Okay, now double check me. If you go to your calculator and let's go to that math prob number 3. And in here we had 4 flavors of ice cream. They asked for combinations because they didn't say anything about order, and we picked 3 at a time. Can you compute that for me?
Yep. We got 4.
There you go. See, these are the 4 different ones that they're talking about. So instead of you and me actually writing them out all the time, this is what that formula does for us automatically. And so we really like the formula for that reason. Okay. What the formula's job was is that if somebody tried to come in here and say, well, I want to put B with C with B, you're like, dude, I already have that one over here, don't I? It's the same combination. The order is different, right?
Yeah, but it's the same
But in our
flavor.
problem, yeah, we didn't say anything about order. It's the same 3 flavors. It doesn't matter. So that's why every time someone says, yeah, but what about, we'll just tell them, well, it doesn't matter though, because the same flavors are in these little areas right here. And so it doesn't matter what order you put them in because they didn't tell us to. So that's what the formula does. He gets in there and takes out all of the repetitions for us for combinations. Permutation, he's like, oh, I want chocolate on the bottom and the vanilla on the top. So there's only one way you can do that. And so if someone decides to flip it, well, that's a different way. So now there's 2 ways to do it. So that's why we get different answers. Okay.
Yep.
All right. So you feel pretty good about, I'll be honest with you. I think if you do have some time tonight, that'd be awesome. And that way you can go in there and you can actually go in there and try all those problems. If you get stuck on any of them, just shoot me an email from my math lab, which problem you're stuck on. Okay. Hey, Priscilla. maybe. I thought she got. No, she's not hooked up to the mic yet. Okay. All right. Well, what I'll do is, like I said, I'll post this Zoom as soon as what has to happen is I have to record it right now. So as soon as it's finished, they'll send me an email link, and then I'll just put it up there under modules for you.
Okay.
Okay. All right. Can you think of anything else? We're good? Oops, sorry.
Yep.
Okay. All right. Good deal. Hey, Priscilla, you got anything that you need?
No, I was just making sure. I don't know if you were doing anything. I just wanted to see what y'all were doing. Kind of forgot I was helping my son with that.
Oh, no problem. No problem. What I was telling Zach, what I do for these Zooms that I'm on my iPad now, so I can actually write on it. And so that way
Okay.
I'll be able to, I'll upload the Zoom link as soon as they send it to me. And I'll put it under modules for test number 3, chapter 11.
Okay.
And I'll put it up there as soon as it gets there. Okay.
Okay. Yeah, I just wanted to make sure I didn't forget something because it's crazy how I'm confused with this math right now.
Oh, okay. Okay.
Yeah.
The main thing, the main thing I was telling Zach was the math part of what we're doing right now is not going to be very hard because everything can be done on the calculator, so it's nice. And the formulas are pre-built into the calculator. So this one with combinations, the big thing about combinations and permutations is just knowing which one you're dealing with. And I think once this Zoom gets published for me, then I'll put it out there for you. Check out the notes or the audio as we went through the notes. It actually allows me on my iPad to do it in front of you. And so I think that'll make it a lot easier too.
Okay, well, I will check those out when they're out there.
Okay, sure. If y'all can, by next Tuesday, if y'all can get the first 3 sections then finished in the homework, and there's not that many problems. And then again, if you have any questions between now and then, by all means, just email me. But then next Tuesday we can pick up. We start with probability.
Okay, you said sections 1, 2, and 3.
Right. 1, 2, and 3 will be the 3 that you should be finished with by Tuesday. Yeah.
Okay. I'll get those done.
Okay.
Thank you.
Well, thanks y'all for coming in. I was gonna do the lesson regardless, so just makes it a little bit easier if somebody's like yes or no or something like that for me. So
yes,
all
I
right,
thought maybe I was
awesome.
like the only one. Okay. Well, y'all stay safe.
Y'all too, and try to enjoy the weekend. Hope we'll have this pretty weather.
Yes, but my son has a lot of math homework and I'm confused.
Oh.
I'm like thinking, okay, if you weigh 32 kilograms on the moon, on Earth, you probably weigh nothing on the moon. But they didn't give him a formula for that, so I'm trying to figure it out.
Oh, okay. Yeah,
so
because
I'm more confused about his than ours.
Yeah, absolutely. Well, isn't it there's a formula for that.
But they're only talking about kilograms and grams, so it still doesn't make sense to me because I found the formula, but they don't need the formula.
Oh, wow.
But
Well, if you think, hey, if you think about it, take a shot of it and send it to me and I'll check it out.
Okay, I will do that. Okay. Thank you.
You bet. Okay, I'll see you guys later then.
Okay, bye.
All right.
All right, bye. Bye, Zach.
Bye.